session or last week. So in this session, we are going to explore more about some more commands with regards to RMAN backups. So without taking much time, I will just switch my screen to my POT screen. Let me just stop sharing once again and share the POT screen. So I have this file here. Let me just go to Oracle NV and set my environment to prod. Okay. So I think last time we were discussing a few things about the RMAN operations. We learned certain things about, I think, on backup types that we have, the targets, sorry, the locations that we can connect to, like the target, the auxiliary, as well as the catalog. And we learned a few concepts about RMAN as well. And I think we did discuss about these configurations or the parameters that we have. Uh, I told you that these values are read from the control file, because control file is our default catalog. Right? So whenever you want to execute a particular RMAN operation, these values will be taken into account unless you override them and type your own syntaxes, right? And now, in terms of now certain other, I mean, additional concepts that we want to highlight here, we want to touch upon, right? So I think last time we started doing some backups also, but at the same time, when you when you come across a term called multiplexing, so the idea behind multiplexing, especially in terms of RMAN, right, is that possibility. Now, RMAN can write data or the backups that it takes to either to a disk or to a tape as well. Now, when I say tape, there will be a middleman, which we call a media server. So our man will allocate the channels, right? So the workers, right? And then using the parallelism, meaning if you have more workers, more threads, more channels, we call it, those can be used to maximize the speed of the RMAN backup operation that you're talking about here. So when you do such operations, it can be handed over to this media manager, who will then do the writing uh, to the corresponding disk tape drives, right, that it manages. So basically, RMAN will not directly write to a tape as such, but we can define channels to support tape operations. So the backups that it takes will be handed over to a middleman, which we call a media server, and the media server will distribute them across the tape drives or whatever the configuration that it has. So there are products available in the market. Even Oracle has a product by the name of Secure Backup, then Veritas Net Backup, Commvault. There are so many other. IBM also has their own flavor of a backing up solution, Tivoli. So likewise, there are many known brands available in the market. So you can leverage one of those tools. So behind the scene, even if you use, for example, Commvault to take a backup of Oracle database, behind the scene, they will be calling the RMAN uh, commands or syntaxes in order to do these backup operations. Okay, so I was referring to multiplexing here. So when I say multiplexing, the real term multiplexing with regards to RMAN happens on disks, right? So how does that happen? Now, when we invoke, right, when we invoke a backup, right, RMAN has that capability of taking data or data blocks. from multiple data files, right? Taking multiple data files, sorry, blocks from multiple data files, and input that to input buffers of the disk, and then put them into a single backup piece, right? So when I say multiplexed backups, which that basically backup piece will carry chunks of multiple data files, data from multiple or data blocks from multiple data files. So that process of taking them from multiple or reading them from multiple data files and routing or putting it to a input buffer to the backup piece is what we call RMAN multiplex. Okay, so if just remember the keyword here, backup piece. So you'll be reading from multiple data files and writing them to a single backup piece. Now the concept piece or backup piece comes only in the form of a backup set. Hope you can remember last time we discussed about a backup set. So a backup set will carry multiple backup, can have one or more backup pieces. So when I say backup set, when I say backup pieces, therefore, we are referring to the term backup set backups, right? There are two types of backups that we invoke. One is backup set backups. The second one is the image copies. So I did not talk about image copies here. I'm still referring to backup set backups, right? So in a backup set backup situations, the multiplexing is applicable where you can take multiple data chunks from multiple data files and put them into a single backup piece. So when you are taking multiple data files, multiple data file chunks, data from multiple data files into a single backup piece, there are certain factors to be considered, right? One is, of course, a parameter that you define, which is the files per set. Files per set indicates per backup set how many files that you can incorporate per backup set, right? So this basically defaults to a value of 64, right? By default, files per set is limited to 64, meaning in a backup, in a backup set backup, in a file set, sorry, in a backup set, you are allowed to have 64 files, right? So in the event if that number exceeds, what happens is that it will go and create another backup set, right? So backup set is a logical kind of a container where backup pieces are where backup pieces would go in. So backup pieces are the physical backup chunks, right? So files per set is one of the parameters that would define the multiplexing factor, and also the maximum open files. So maximum open files defaults to 8, right? So if you invoke a backup, you can set your configuration in order to set your maximum open files. So that means at any given time, how many files you can read. Concurrently, how many files you can read. That is what maximum open files does. And then also I told you in a backup set, what is the limit of files that you can accommodate, right, in a given backup set. So those are the two factors that will determine the multiplexing factor. So let me just take one example for you to understand this, okay? Now, let's do this. Let me run what you call a small script, right? So when you are running multiple lines of code within RMAN, you have this facility of using a run block. So run block basically starts with run and then open curly brackets, and then you keep typing your RMAN commands in a sequential fashion, and then you can close the curly bracket, and then you can let the whole execution to take place, right? So these can be actually stored as scripts as well. If you store them as scripts, you can actually store them in the catalog database as well if you want, right? Now here we don't use a catalog database. We are using the control file because it's a default one, and that is sufficient for us. But in the event, if you really want to store your scripts as well, you can make use of the catalog database as well. Okay, fine. Now here, I would say backup. Okay, let me just do one thing. Uh, Now here I'm allocating a channel. Right? So you can have one channel, you can have many channels, but if you can remember here, recall here, yeah, I have a device parallelism set to 2. So device parallelism set to 2 is a default configuration, and you are going with backup set backup. So in a backup set backup, if you invoke, right, by default there will be 2 channels open. There'll be 2 channels open, but in my case, I'm running a separate script here, and I'm going to explicitly say that I only want 1 channel. So with this 1 channel, I will be able to explain this in greater detail. So that's why I'm just picking 1 channel instead of 2 here. Or I would have said, I would have configured this by saying configure device type disk parallelism 1. Right, backup type to backup disk. So sorry, backup type to backup set. So that way I'd be only invoking 1 channel. Right here, I'm overriding the default one, which is 2. Now I'm having only 1 channel allocated. Right here, I would say backup uh, files per set. Okay. Okay, so the second line, I am saying backup files per set 10. Now, the files per set parameter is something that you can run, that you can mention during your backup along with the backup command. All right. Okay, now I'm going to give you an information here, that is, if you can recall, files per set by default, I mean, the default value is 64. Right? In a backup set, you are allowing 64 files to be backed up. But here, I'm going to say in my backup set, right, I'm going to accommodate only 10 files. So in the event, if you have more files in my database, because it's a database backup that I'm going to invoke, in the event, if I'm backing up more, then first file set will be over, and then it will go into the second file set, right? A backup set rather. Now, so this is that 10 that I'm mentioning instead of saying 64, which is the default, right? But then there are 2 factors affecting the multiplexing factor, right? One is the files per set. What is the other one? And the other one is maximum open files. So maximum open files, that means at any given time, how many files you can read, how many files RMAN can read, a channel can read, is limited to, by default, 8. Right? Now let's say when I invoke this, now I have 10 here, but the default value of maximum open files is 10, 8. So I will give you the figure here, and then let's see whether RMAN is actually using the same. Now what happens is when you give files per set as 10, right, and your default value, because open files I have not mentioned here. So if maximum of open files defaults to 8, right? We have 8 and 10, right? So how would RMAN determine the multiplexing factor? It would be the lesser of one of those, right? Lesser of the 2, right? So here files per set is 10, but my maximum open files is 8, and therefore, right, if I run this command, theoretically, we should see RMAN, or this single channel, right, takes 8 data files at once to process the operation. Hope that is clear, because it should be the lesser of the 2, either the files per set or the maximum open files. So maximum open files, I have not given any value here, which means it will be defaulting to 8, and my files per set is 10. So even though this is 10, since my open files is maximum open files is 8, which is less, right? This channel will take, or maximum will take 8 data files when it is being read. Okay, so let's see whether it is this case, right? So I'm going to run this command. So it is allocating channel 1 and it will be a single channel. Okay, so you can see now channel 1 starts the backup, and these are the files that it had got taken into the channel. So let's try to count the number and see 1, 2, 3, 4, 5, 6, 7, 8. So you can see here clearly that it has actually taken 8 files, right? So this is an example of multiplexing. So it has taken 8 files. So now the RMAN, this channel CH1 that I have given name, CH1 now is reading data chunks from all these 8 data files at once and placing them into a single backup piece, right? So now since this is the backup is still on, but you will realize later on, you can see here now, it says backup piece handle, right? Now this is that backup piece that I was talking about. So it has a backup piece name, right? So it has a system generated name. Don't worry about that. However, this backup piece is carrying 8, sorry, this backup piece is carrying 8 data chunks. Okay, right. So that is how the multiplexing works, right? So now here you can see it goes into the next piece. It generates a second piece, but this time this piece is only carrying how much? 1, 2, 3, 4, right? And 1, 2, 3, 4 here as well. Most likely the reason is, okay, now if you are running your, if you are having a multi-tenant, or if you have a multi-tenant architecture, right? So these are separate databases. These are pluggable databases, but they are still separate databases, right? So in each database, right, there would be by default 4 data files. So they are not combining, since these are, I mean, theoretically, you should not be combining them as well. Why? So if you put all the data chunks into a single piece, then there is a compliance violation also, right? So in the event, if you want to isolate your backups, then if some parts of one of your databases content goes into a backup piece of a different other database, then it will be a problem, right? So that might be most likely the reason why they're not taking those chunks into the same backup piece, right? So that's why. So if you take the firstmost one, so the firstmost one is actually from the root itself. So this is from the root. So root database is having maybe 8 data files, or maybe, yeah, I think it is only having 8 data files exactly, right? Because these are actually from a different pluggable database, right? So therefore, so that should be the reason there, right? So I just wanted to give you an indication of how multiplexing works. So hope that part is clear to you. And next, what we have to understand is the compressed backup. So let me just go to compressed backups as well. Okay, so now if I say show all, if you do right, so here you can see down somewhere here, you can see here there is a entry called configure compression algorithm basic, right? So apart from basic, you can go with low, medium, and high. The term low, medium, and high means Oracle or RMAN is going to use certain different algorithms in order to increase, right? Increase, or in order to vary the compression ratio. So if it is low compressed operation, it will be Oracle will use an internal There are names also for these algorithms. So one algorithm will be used. If you use low, that means your compression ratio is less, but the time to complete the backup would be faster, right? Similarly, if you are happy with a mid-range compression ratio, you can go with medium, right? But if you are expecting a high ratio for your compression, then you may go with high. But the time of RMAN backup completion would be more than, right? So now what's that? What's the difference between those three and this basic? There are two major differences between the two, right? The low, the medium, and then the high, right? They all occupy a certain algorithm to do the or to achieve these compression levels. Whereas basic, it uses two mechanisms to do a compression. So although we call it, although we call it compression, it may not, you may not see it as real compression, but however, how basic achieves the compression is by not taking never use blocks. Let's say as an example, you have a data file in your database, but you have used data up to, okay, so your maximum size, let's say you have set it for 30 GB, your data file size is 30 GB, but only up to 25 GB you have used, right? So then, when RMAN takes the backup, it will not take that additional 5 GB which had never been used, right? So that way, your backup size will be smaller because you are not going to use, RMAN is not going to take the blocks that had no data at all. Similarly, RMAN can skip the null block as well. What do you mean by null blocks? Those are the blocks that had previously data inserted, right? Previously, there were data in these blocks, but now they are no more. So such blocks can be skipped as well. So by skipping those null blocks, by skipping unused blocks, right? Basic at a basic level, the compression can be achieved. All right. Right. So then the next question is, so that is but that is one of the key differences. I told you there are two differences. This is the main difference, right? Now the next, before explaining about the next difference, you may now wonder, then why we always go with basic? Why can't we go with low? Why can't we go with the medium or high? Right? The reason is that Oracle has something called, here I'm using Oracle Enterprise Edition. Oracle Enterprise Edition has certain options available. Now, what do you mean by option? Option is a facility that is given to you, but at a rate. So if you are having Enterprise Edition, you can opt for these Enterprise Edition options, but you have to pay in order to use these options. So now I come to the second difference between those two types of backups, right? In basic compression is basically free of charge. Okay. But if you're going with an algorithm like low, medium, or high, right, then you have to obtain the license or the option license, which we call advanced compression, right? So advanced compression will allow you to use those low, high, medium algorithms in your RMAN operation, right? So it is not just these RMAN compression that you will get if you're having advanced compression. There are other compression scenarios as well. For example, when you're taking a data pump dump, and if you want to compress with one of these algorithms, you can use that. So you're entitled if you have your advanced compression license. At the same time, when you want to, if you have a primary and a secondary site available, right? If you have primary and secondary site available, and then let's say this primary site and the secondary site has a huge lag in between. So now you want to push these changes, a bulk load of changes from the primary site to the secondary site. In that case, right? In that case, you'd be able to uh, to reduce this gap by sending data faster by way of compressing these changes as well. So that is one of the other advantages that you get, that you would have if you are having advanced compression, right? But it's not relevant for us, but I just mentioned to make the things complete. Okay, so basic therefore is free of charge. So that is why it is given by default, right? Because the moment if you use if they have given let's say low as the default, that means you have to pay in order to use it, right? So you don't need to do that. So because it's optional, you don't need to. It's not necessary that you have to incorporate compression there, right? And so let me just give you one example. Backup as compressed backup set. Let's say data file, or let's say tablespace. Tablespace. What shall we? Let's say PDB PDB2 PDB2's users tablespace. Oh, backup as I'm sorry. Backup as compressed backup set tablespace PDB2 users. Okay, so here we go with the tablespace backup here, and you can see here it's a compressed backup that I'm incorporating by mentioning compressed backup set. Now, another important thing that you have noticed, that you would have noticed, is when I use this command, I said backup as compressed backup set. So compressed backup set again, right? So backup set backup is this. Again, this is not an image copy backup, right? Now we came across two features. One, the possibility of multiplexing your backup, right? Second one is the compression backup. Multiplexing and compression rather can only be incorporated with a backup set backup. All right, just make a note of that. So if you want to compress it, or if you want to do a multiplex backup, then always you have to invoke a backup set backup, not a image copy. Right. So let me just before going into image copy backups, let me just do one more thing. Let's do something like this. Backup. So you can see the data file number is 25 here, right, of this table space. So I will just do backup section size. We'll give 100 in data file 25. Okay, now you can see here, I incorporate a different type of a backup here. Okay, and this backup does a section size. So we have included something called a section size. Now, what does it mean by a section size? I don't need to necessarily give a data file to backup, but I would have said a database as well, or table space, or a data file. So last time I invoke a table space, so I just mentioned data file here. Now the understanding that you have to have is, now in this case, I'm splitting a given data file into pieces, right? So is it similar to multiplexing? No. Right? So what I'm trying to do is I'm going to split my data file into chunks, into pieces, right? So that I will be able to have multiple pieces so that it will be easy for me to transport, right? Let's say if you have a extremely big file that cannot be accommodated in a single, let's say maybe a tape drive, right? So what I can do is I will, because now I think during our administration sessions we would have discussed about big file table spaces. A big file table space is a huge file, but it can only have one file in the table space. So if you can only have one file, that file has to be extremely big, right? So sometimes if you are trying to back up such a file, your tape drive may not be sufficient in order to put that entire file. So the best way is by splitting the file into small chunks. All right. So therefore, this is what you call section size. So section size is not multiplexing because section size will determine how we can break the file at the time of a database backup. So they are not going to merge multiple data from multiple data files into one piece. All right. So make a note of that as well, because that is also important. Right. Now, so that's about the section size. Okay, now let me just introduce you to image copies. So when you are taking an image copy backup, now the difference between an image copy and a backup set backup is that image copy is somewhat like you take a operating system copy of a file. Now you use the copy command and then you take a copy of a backup, file. Similarly, RMAN also does the same operation, but that will be recognized as a RMAN proper backup. But because it is actually invoking through RMAN, right? So image copy backups might be sometimes bigger than the backup set backups because it doesn't go into block level, right? I told you if you are using basic level compression, even unused blocks, right? The never used blocks, right? And also the null blocks, right? So those are all eliminated at the time of when you use basic compression. But basic compression is not applicable for image copies. So hence, your image copy most likely be the same as the file size that you already have in the target environment. All right. So let's quickly do one backup. Okay, before that, let's do select asterisk from $, recovery area usage. Okay, so you can see here there's one image copy that we have already taken. I don't know whether we attempted last time as well, but anyway, you can see there's one copy, sorry, one file, and then the current recovery area usage is 2.49. So I think, if I'm not mistaken, I had explained you about the retention time, right? Let me just quickly do that as well in case if I have not done it before. Show parameter recovery. Right? You can see here that the size is given as 1 GB, right? So this total amount that you are seeing here is from 1 GB, right? So from 1 GB, 35% is currently used by the backup set backup. So those are the backup pieces, right? Backups of archive logs, or maybe not just the backup, but the archive log files have been using 3% likewise. Okay. So similarly, image copies, you can see 2.49 has been used. And then you have the reclaimable space as well, right? So this reclaimable space is because it all depends on the retention policy that we have. So in here, configure retention policy redundancy 1, right? So if the same file has been backed up 2 times, then it becomes redundancy. Redundancy 1 has been violated, not violated, but it's exceeded, right? So because you can only maintain one. So the moment you have 2 exact copies of a file, then what happens? One file of that one backup will be marked as obsolete. So the moment you mark that as obsolete because you don't need 2 copies, then the file or the backup will be still there in the recovery area, which has a maximum of 1 GB that we have defined here, right? But it will be marked as reclaimable because now that it is not fitting to the policy or retention policy, still it will be maintained, because in the event if there is a space pressure, these can be simply taken off. Reclaimable space can be taken off by deleting those obsoleted files. Because last time I think we discussed about obsoleted files and the expired backups as well. Okay, right. So that's it. So let me just go back to RMAN once again. Right. So here I would do backup as copy pluggable database PDB2. So this way, I'm taking a copy of pluggable database. So it's not a backup set backup. You can see the syntax difference. I'm taking an image copy, right? So parallelism will be set to 2 because the default parallelism is 2. So there will be 2 channels allocated, unlike last time, where I explicitly wanted 1 channel to be used to showcase the multiplexing effect, right? But here it is using 2 channels so that the activity will be completed fast. So when I say activity getting completed fast, of course, not necessarily the case, because you need to have sufficient resources to do that. Okay, so if you don't have enough resources, then it will still take more time to finish. Okay, so in this case, it is going fast. And also my database is small, and hence it would not take that much of time to complete the backups. So we have come to the last stage of the backup, where it takes the backup of a control file as well as the SP file. So it should be over right now. Let's recall this or check the recovery area usage. Select as from $B recovery area usage. Okay, so you can see now from one file image copy, it has gone up to 5 because that PDB had 4 files. I think you would be able to recall that as well. So now it had gone up by 4, right? So that's how you take image copies. Image copies cannot be multiplexed. Image copies cannot be compressed, right? So you cannot use those two against an image copy. Okay, so but still this will be considered as a valid backup also, right? Okay, so let's try this one. Backup duration. Backup duration. What can we backup? Shall we backup PDB q dot users? Oops, there is a problem here. Okay. So the issue here should be retype it. Let's say backup minimize time. Oops, I think. Okay, let me try again. Yep. So minimize time. Let's say table space PDB2 users. Okay, so this is another interesting way of taking backups, right? So you can specify time duration, such as 2 hours here, and then you can let RMAN know how fast you want to finish this operation. Do you want this operation to be completed immediately, right? Or, I mean, if if you want it to be completed immediately, then you need more resources, right? So over the rest of the activities in the database, RMAN will be given priority to complete this task. In how many hours? In 2 hours, right? But here the thing is that I said minimize time. So when I say minimize time, I'm asking RMAN to finish my operation as soon as possible, right? Although 2 hours. So 2 hours is the boundary, right? Things have been slightly different. I will not run it here. If I had put minimize load, right? So when I say minimize load instead of minimize time, what it would do is it will try to occupy this entire 2 hour duration in order to complete my backup, right? Of course, it might not exactly go till 2 hours, but it will try to do that, right? If there is no impact at all, I mean, if the database is idling and no operations are happening at the database level, then of course this might also finish fast. But in the event, if you put minimize load instead of minimize time, the objective is spread your RMAN operation or spread your backup operation throughout this 2 hour period and do not impact the ongoing database operations. Okay, so that's an important syntax that you probably need to remember. Another thing that you might wonder is that what if the given time is too short and you cannot finish exactly. I mean, okay, so your database size is, let's say, 6 TB, but you want this backup to be completed in 2 hours, and the resources are not big as well. So there is a chance of RMAN cannot finish anyways within these 2 hours in completing a 6 TB backup. So still, let's say after 2 hours, it will fail because it will stop. The backup operation will stop because you have given a time limit of 2 hours. But what happens is that whatever the backups that it had taken until that time will be considered valid. Right? Of course, the rest of the backup pieces or backups uh, might have not been taken, but up till such time, up till this 2 hour duration, whatever the pieces that it had taken will be considered valid. So it can be used, or those can be used for recovery operations as well. Okay, right, fine. So I would like to introduce you to an encrypted backup as well. I hope that will work probably to this time. Let me just show you how we can do that. Okay. Now, show all will also give us some information about encryption as well. Okay, let me just take that as well. So you can see show encryption algorithm AES 128. So AES 128 is the algorithm to use to do the encryption by default, right? So AES, DES, you can use anything that you like. But again, encryption is a paid option. Although I'm demonstrating here, you still have to pay for it if you really want to use it. Okay. So since this is a development environment, I can use it for demonstration purpose. But if you want to use this, you need to purchase the license or database option called advanced security. Again, just like advanced compression, advanced security has many other features as well. This is just one of them. Okay, right. So what I want to say is that if I run this, okay, so if I use encryption, encryption has a single mode and dual mode methods, right? One encryption mechanism is to have a master key created, and then based on the master key, you can have your backup key, and then you store it in master key will be kept in a wallet, and then you take your backup, and you need to have your master key in order to open the backups that you have that you have taken, right? So that is one mechanism. The second mechanism is to incorporate a password in order to encrypt. So password encryption is also available. So you can choose between a wallet and a password, or you can use dual option as well, meaning you can use both as well, right? But for my demonstration purpose, I will only be taking what do you call I'm going to take only the password based encryption. Okay, so what I'm going to do is I will show you first up. Okay, so let's try show PDBs alter session set container equals PDB1. Select asterisk from spot.dpt. Okay, so you can see here the spot.dpt is part of the PDB database, and it's select table space name from DBA tables, where table name equals DPD. Okay, so it's in the users table space for PDB2, because sorry, PDB1, right? We are in PDB1. So let's figure out the data file. We have that. So RMAN /, I'm getting to RMAN once more to take the backup now. Okay, so now report schema. Oops. Report schema will tell me the PDB1's users table space, where it is. So PDB1 users table space is data file number 16. Okay, right. Let's take a backup. Backup. First, we'll take probably an encrypted backup. Okay, so for me to do encryption backup, encrypted backup rather. So let's enable this one here. Set encryption on identified by password 123 only. So instead of using dual mode, I'm using the single password mode. That's why I'm saying password. This is the password that I'm going to use to do my encryption, and only is the keyword to use, that I'm only going to use password encryption. Okay. So backup data file. So a file number where we have our what do you call, department table was 16, right? So backup. Let's do this. Backup data file is fine. Backup format. Put it in user or sorry. tmp slash enc underscore %u. So %u indicates that my piece has a unique name, right? U, and we'll say data file 16, right? If I'm not mistaken, this is 16, right? So this is a file number which we have first, right? Okay, so let's try to run this. Okay, now it is invoking theoretically backup that has encryption enabled, right? And it goes and stores that file into this location /tmp enc underscore and a unique name, right? Okay, now let me just set my encryption off. Okay, so I'm using the same. This time I will type in the same line, backup format /u01, sorry, tmp un enc %u data file 16, right? No difference. I mean, just that I have a disabled encryption here. So no encryption, right? And then data file 16 format there, and then just that type of use unencryption here, right? So let's try that. So it has also taken a backup now to tmp un or unenc underscore and a unique name. So let's go there. Okay, so we go to cd tmp, observe the two files. So we have the enc and unencrypted file as well. So let's try one. Yeah. So first we'll try with now there's a command called strings, which is available in Linux to read string values or text values from a file, right? So I use this against my unencrypted file and will grep to we had the counting, right? Okay, so you can see that the term accounting is getting repeated. So although it is not really, I mean, we only queried one value, but see the counting value is there anyways, right? So let's try maybe like sales. Yeah, so sales is also getting repeated. There are other places where you have salesman, right? So it's interesting that you can read these backups. If you have text values, you'll be able to read them. Right, quite a lot of sales values are there, not just sales, but salesman, sales, and so on, right? So this is the backup basically which has the EMP and EPT tables. Okay, so similarly now we'll just erase this file. I mean, take off this file, and we'll check the encrypted file for sales. You can see that sales or even accounting, nothing can be seen, right? So purely because they are physically encrypted. So this is that important. This is the importance of using encryption, right? And this is for a backup. So mind you, even though we are dealing with a backup file here, even if you can take one of your data files out, right? I mean, and then you use the strings command against your file, right? You'd be able to see all the text values that you have in the file, right? So that is why if you encrypt it, of course you won't be able to see that. I mean, read them. So that's a very important point. Just that here for RMAN encryption, you need to have licenses used. But then still it is still worth it, right? Because so in enterprise edition, you have something called as transparent data encryption, TDE, where you can encrypt your table columns, table spaces, or the entire database. And so you have different levels of encryption that you can incorporate with dual key encryption mechanism. You have a master key, and you also have a data key as well. So you need the master key, which is stored in the wallet. So master key opens the data key, and that when you have the data key open only, you'll be able to read those encrypted columns or tables or content in the table spaces or database. So either way, so you need to have those security features enabled as well, especially on your production, and especially when you have your sensitive data in place. Okay, so so those are the areas that I wanted to touch upon today. Hope I wasn't speeding up too much. I just wanted to make sure that today how somehow I managed to cover up all whatever I was planning to do. And so yeah, so with that, I think we can wind up. I'm sorry, we can open the session to questions. Kavindu?
Yeah. If anyone have any questions, you can ask. But I have a one question before that.
Yeah,
Uh, in parallel execution, if we have set the parameter for 4, that means it allocates 4 channels, right?
that's correct.
So, so in executing with 4 channels, does it utilize like 4 CPU cores, or does it utilize something else?
Yeah, so basically you can assume it to be 4 CPUs, but we cannot bind them to 4 CPUs, Kavindu. So yeah, but what I mean, generally what we are expecting Oracle to do is to allocate those 4 channels from 4 CPUs. So
I see.
because in the syntaxes we don't have a a capability to provide the exact I mean how this could be whether a channel can be bound to a specific CPU. You can't, there's no syntax as such, but behind the scene that should be the case, and that is what we expect it to do as well.
Yeah, I understand. Yeah, thank you.
Yeah, no problem.
So I'll stop the recording for now, and if anyone have any questions, they can ask. Yeah, go.
Sure.